Hello good people of the internet. Today I want to talk about a surprisingly useful, really lazy file format that I've been using in a bunch of my products and I hope you guys will find useful too. The aim of this file format, I call it lazyf, is to provide a lazy way of doing something like JSON, particularly a human writable one that looks like what it does. So my main use case for this in the first time was to write designs for cards. I was making a board game. It had varying cards which all had different abilities. I needed to write all of those abilities. I didn't want to get stuck with all of finding the right commas in the right places and things like that and making sure that it was solid JSON before trying to do this. So I wanted to make a format that was easier to write for. At the time I was working in Python and I made a very specific parser that handled it for exactly my case then. More recently I've been working on a couple of other games. Another game needed cards which had different abilities and different properties. The same format felt useful. After using it before, I liked it. I used it again. I needed to reparse it, but this time I thought, well, I know the pattern now, especially when I needed to do it for another project. So I've had to use it 3 times and I find it a useful format. Let's just do a quick demo of it, shall we? So if I make a directory and I'll call it test data, because of course I'm working in a Go drive, and in test data we'll make army.lz, short for lazy, right? So as I said, the aim of this file is to create a way of structuring data and reading it quickly into a struct without having to write so much complicated stuff. So, say we've got a bunch of different kinds of soldiers in our army. This is a game I was working on recently, and it felt helpful to have. So, infantry. Now, first thing I do is I give them. They have a standard health, so maybe infantry have a standard health, and then they have a range, which would be maybe 4 tiles. They have an attack of 3. They have an ability of actually they don't have any ability, so I won't give them an ability. And let's do riders. And they have a range of 6, attack of 2, and they have a range, no, an ability of dash. We'll work out what dash means at some other point, and we'll make one more character type for this. Ignore the meaning of the numbers. The basic principle here is we have a way of writing these cards. I'd say that this is easier to read than JSON. So if you disagree with me on this, then probably this video is not the video you want to watch. If you think that this is a reasonably easy to read file format with tabs defining the stuff, then I will show you how you can pass this into a struct with my, I guess, main.go. We'll yeah, we don't need that. So the first thing we're going to need to do is define a type. In some ways this is actually it's a unit type, isn't it? So all of the information, unit type, and that's a struct. So this is the information about the unit type, not about an individual unit. So that's not quite the same. I feel like if we were doing JavaScript, we could use prototypal inheritance on this really nicely. We're not doing that. So I have this unit type. Obviously we decided that it has an attack. Call it name here. Name a string. Attack is int. So I'm going to use the lazy format. Units, no, u types, colon equals, oh, and error. Lazyf dot read file, and it's test data / army.lz. So hopefully this is what we have. It's brought in, it's imported to my library. This is what I'm actually introducing, and hopefully you'll see github.com, code of convoy, lazyf. This is my library for parsing files that look anything like this, really. There are other ones. I'll show you some examples nearer the end of some other file formats I've used that look surprisingly similar. And once we have done this, we have a struct, a slice. U types is a slice, okay? So for k comma v colon equals range u types, let's have our army colon equals army types, and this will be a slice of unit type, and let's make our constructor. Okay, so we'll have func new unit type, and this will take a lazyf.lz, which is the main type of object in here, and this will return a unit type. That has no need to return an error in general because it will be able to do stuff, and we'll call this LZ. So this library doesn't work like JSON marshalling and unmarshalling. I found that this would be simpler to allow constructor creators. I mean, this file format doesn't do everything JSON can do, right? You can't go deeper. It's only one layer deep. And for my purposes, that's fine. It's actually fairly straightforward here. Return unit type, and then we'll fill in its details, right? Name. But how do we get the options? How do we get name? Well, sl dot, and I'll show you the list of options we have. So, pbool, pull up a bool. pbool pull up a bool, but with a default if there's an error. So I've provided in the library an option for pulling anything up or for using a default. So we can pull up booleans, floats, ints, or strings. I didn't bother with anything else. If you want to write converters for those, feel free. Now name is obviously a string. Actually, we don't even want that because name is dot name. But attack will be lz.p int, and we'll use a d, and that d is for providing a default. So the standard attack for any creature will be 2. Otherwise, we will look for attack. And maybe they spelt it, maybe they wrote AT because they couldn't be bothered, or maybe they wrote at. Okay. So this actually allows me to receive multiple options, and if they wrote any of those, it will find this one first. If it doesn't find anything there, it will look at. If it doesn't, it will look at AT. It's stored in a map, so this was the easiest way of doing that. Stick a comma on. And if it can't find any of those, it will put 2. So that's safe. It's not going to throw an error. This will not complain. Health. This, on the other hand, was the number we put after here. Now, I put those in the map at EX, okay? So I'll show you an example. So we actually need to get lz.p_int_d, and again, we'll put a set of default health. We'll set the default health to 2, and then it's EX1. I guess we could actually allow for health here as well if someone, instead of putting it on the end, decided to put health in. In fact, let's test that. Let's get it off from here. and write yeah. This should not come up with any problems, you see. Did they have range as well, didn't they? They have range and attack range, so I didn't bother with range. Let's put that here, range. And that will be lz.p string d, and there's no ability by default. Ability. Okay, so we now have our constructor for these. We pull through in our main function. If error does not equal nil, log.fatal error. Okay, so if we have any problem with the file, we can reveal that. Probably shouldn't be doing this in main, probably should be doing this in a testing library, but I just wanted to demonstrate how you can use this. So now the next thing we do is we just go army types colon equals append army types, and with that we append new unit type, and this will take v, because v is of course running through is a u type. So underscore that. Now so for the sake of showing that this is loaded, I'm just going to quickly run through and print them, okay, as well. So for underscore comma v colon equals range army types, what we'll do is funct.println %v just, and we'll send it v, and then hopefully we end up with a result that looks basically correct, right? Let's try and quickly compare that with there we go. So the infantry has, there's no 5 on that infantry. Oh, it's not EX1, is it? We start counting at 0. So let's try that again. We go run. So now we go. The infantry's health is 5, and the rider's health is also 5, but the catapult's health is 3. So that has worked. A minor mistake, the fact that it's EX. So that is the problem, of course. You don't get errors through if you've written it wrong. I guess that's what unit testing can help you with when you're trying to find your problems. So I did print line and then told it %v. Oh, how silly. So anyway, we can read the content of the struct. We're happy with that, and it is that simple to use. So that wasn't a whole lot of work. You certainly didn't have to write any difficult parsing to use it. Just got to grab the stuff you want. Now let's see how this does handle errors when it tries to parse. So if I take this infantry guy, and I just get rid of that colon by accident. Okay, and then I run it, and it shows an error trying to read it. It says on line 2, no colon. Now where was that error? The error is on line 2 and there is no colon. So I guess I didn't know where to find it, so that there are errors. Another error, of course, is that someone could write their thing without doing a type, so it's worth clarifying that. And if someone writes a colon, then we run this. Go run main.go. We end up with an error. No object was defined before you're doing that, and the error's on line 1. So it doesn't know what it's working with. So just so it does handle errors in the file appropriately. So you can do that. And it will even find 2 errors if I get rid of that change and add this no colon. We should get 2 errors. Yeah, so error on line 1, error on line 4. So it just carried on trying to read it. A couple of other things you can do if we get rid of the errors. I decided to give comments on starting with a hash. No problem. And empty lines don't do anything. So hopefully this format will be of interest to you. It's certainly very lazy, but there are some advantages to a little bit of laziness from time to time. This does mean as well that I can show this stuff to my wife and she can look at it and find all the properties and think, yes, yes, yes. She's not a programmer. She's not necessarily used to JSON. I'm sure she could read JSON, but when it comes down to it, simpler is better, I find, and this works. So back to the main library. Let me show you what this looks like from the inside. So I'll show you all the files. We've got the main.go is where all the parsing happens, and they've got a parse test, and we've got a config which checks for things like this. I also added a variable scanner, so you can actually, if you want to include stuff like environment variables, I put a mechanism in for that because it felt useful. I'll maybe show you that in a minute. So we'll open up main.go first and just take a quick look at the parsing mechanism. So internally, every LZ has a name and a map of string to string. When you try and parse the whole thing, parse LZ is perhaps not really an external API thing. It takes your first line and makes the API, gives it a name and sticks any extra stuff after the colon in the first line on the end, just by looping through after splitting it on a colon and a couple of trimming spaces. So nothing particularly fancy there. In fact, there's nothing really fancy in any of this. The main read method takes a reader and then returns an LZ, or of course an error if it has any problems. It uses a scanner, so to do a scanner you just loop through buffer new scanner, scan, and I count line, and then we just run through and we look for things. So if the length is bigger than, if the list has a length, if the string has a length of 0 after being trimmed of white space, we don't bother. If after being trimmed of white space the first character is a hash, then it's a comment. Don't do anything. This was a bit funny, but of course the TR is trimmed and T is the actual text. So if after trimming it the first character is the same as the first character before, then it means it didn't have any white space before. Perhaps slightly dodgy, and I know that I've got a character 0 because I've already tested the length, so I can parse. I just create one here and stick it on the list, and because the map is really a pointer, like it doesn't say pointer to map, but maps work internally with pointers. It meant that I could always add to the details when I wanted. This is a check that the current actually exists. If no one has made a current creature, the current object, there won't be a map for it. So this would throw an error, and that was that case where I wrote the thing on the very first line. So that's a bit of protection against that. And finally, we just split the string on a colon, trim both sides, and then try and append it, stick it into the details by the left side and the right side. And if we get a problem, what I actually did was I stuck the errors in this list of errors, which is actually an error in its own right. That's something I wanted to talk about because I really like the way Golang handles errors, and what this allowed me to do, if I open up error, it was line error, wasn't it? Lineerror.go, was I created this error group, which was itself an error. And when you print out this error, it just ranges through all of its errors inside it and prints them out. But you can also get an n errors, which allows it to fulfill a separate interface, which means you can tell other people that this is an error group, that there are multiple errors and that it might want to do something slightly different. We also have a line error, which is an error which stores a line number, so that we could, if I wanted to do something with that later, I could give a list of all the lines errors happened on. I haven't done anything else with this, but there is a place where this came in handy. And in config.go, this is actually my mechanism for loading up config files. So the main place the error group came in handy was in this method, in getConfig, which actually reads a config file for various programs, because you can pull out and store default stuff for programs relatively easily in this format. I started using it as my main config file format. And a couple of handy things that I thought was to do was to be able to provide a list of locations and scan through. And there were two kinds of errors that were possible with the read file. The read file could either return an error where it couldn't find the file or couldn't read the file, or it could return an error group if the file had parsing errors. And so I looked for this n errors. I tested to see if I could assert it as something with n errors, which was that method the error group had. And if I could assert it was an error group, then that meant I knew that I'd found the config file, so I should return the error as it was and not look for another file. And then I was able to just give a list, maybe 4 or 5 places where configs live, and it'll find them. And I actually had one which pulls out just the single LZ in case, because most cases with config it's just a single lazy item. Back to the read file. The read file is, of course, it takes a file name and it opens the file. The file is a reader, an io.reader, so it's very easy to send to the read method, and the rest is just making sure there are no errors and closing it. That's almost a non-method, but it's, you know, it's appropriate to have in a library like this. And then the rest are just uses of pstring. So pstring reads a list of strings and it just tries to find it in that array. If it can't find any of them, it'll either return a nil string with none found, or the first one it finds will return the result, which allowed for normal stuff like pint to pull on pstring and try and convert them. And the only other useful one was this array where I treated, you could ask for a specific value like ex and just pull them out into a slice of string. And if it couldn't find any, then it would return a slice. So the usage of that, if we go to back over here, we could actually do range 0, range 1, range 2. And what would happen then is you'd end up with a slice. If you look for string r on range, you would end up with a slice with the numbers 1, 2, and 5. Oh, well, it would be strings 1, 2, and 5. So that's where that could be handy on occasion. I haven't actually used that, but it felt handy, so I wrote it. So another place that I've used this file format is actually in my configuration files. And I'll show you how and why I've done this. So if we open up the configuration file that I've just written config here and then just put in colon separated data. But by having this organized in this particular way, there is some benefits to my general code. So I'll open up my main file. Primarily this is for the main function. What I've done is I've got a flags for user options, and most of these can be set the same things as can be set in the configuration file. So when I run them, there are places, so for example here, I've loaded the configuration file using the getConfig method, and I sent it a list of locations, or whether I was willing to go without a configuration file. And no. So I've loaded up the configuration file. This is actually a method belonging to this package that calls lazyf.getConfig with various options, but mostly just lists of configurations, possible configuration locations. Once I've got this configuration, I can then just pull out the data as I want it. So when I was trying to work out where to find my users, and obviously I have a user file for this, I had to decide where that was going to be, and this can be chosen by a flag, a user flag. But if it's not set by the user flag, then it will either be user data or whatever was found at user file in the site main config, in this case test data user data.json, which gives me a bit of freedom to make it whatever it will be, and it's just a single line to pull that possibility. So either have a default or use it from the file. And I actually also used this environment replace because this is a method that I haven't mentioned yet, but if I want to be able to write something like, I've enabled it to work with this. So if you've got a home location, then you can do that, and that's by running this environment replace on the location that comes out from here. And another useful place this turned out was for, and the main reason I bothered with this, but I don't need it on my local server, just the one that's running on my server, is this choosing the right key, private or public key, where have I put them. I really needed to be able to say where. And so in my config file on my server online, there is a pub key and priv key and the locations of them. This has made my life a lot easier, just to be able to pull them, and also to choose the port as well, because that can come out of the config file and just work. And again, it's got a port if I've not chosen one in the config file, but if I've chosen one in the config file, then it will be a different port, and that's okay. So this is what I was aiming for, and this is why it has a config file option. So hopefully this library will be of use. If you think it's a handy library, let me know. If you think I'm silly to try and use anything other than JSON when JSON is a perfectly good standard and it already works, let me know. If you think there are any things you can do to help or to make this more capable, let me know. I'd love to hear from you. Please take a look at the library. Please make your comments. Please make your pull requests. And we'll see where it goes from here. See you soon. Bye. What are you still doing here?